Okay, so in this video I want to look at this concept of functions. So we'll look at the basic definition of a function, how we go about writing a function and the different parts of a function, and we'll also look at why do we even use functions. So let's get started. Okay, so a function is just simply a named set of statements. And we can have functions that are defined by the C++ standard library. So like in our previous program, we looked at using the size and the at function in order to get maybe the length or the size, how many characters we had in a particular string, or maybe retrieving a particular character at a particular position in a string. But we could also go about defining our own functions. So we may define a sum or square, a volume, maybe for a rectangle or a sphere, calculating the square root. So we're not just limited to the functions that are provided to us by C++. We can go out and define our own functions. All right, so let's look at how we go about defining a function or writing a function definition. So we have a function definition here for volume of a rectangular prism, and we just simply have named it here vol of rect prism. And so I want to just go through and look at the various parts of a function definition. And the very first thing that we come across is the return type. So we'll just label this return type. And the return type is just specifying once we've evaluated or run this particular function, then it has to return a particular value. In this case, it has to return a value of type int. And the next thing we see is the actual name or the identifier of the function. So this should be meaningful in terms of what this function is going to do. So from this, we get a sense of this is going to calculate the volume of a rectangular prism, even though we've abbreviated it. Also notice the naming convention that I've used. This is fairly typical for function names in C++. First word lowercase, and then every subsequent word there is in camel case. So if you only had a single word function name, then it would all be lowercase. Again, this is just a convention. It's not actually required by the compiler. And then we have what's called the formal parameter list. So all this stuff here inside the parentheses is part of the formal parameter list. And this is how we actually get data passed into this particular function here. So we're interested in passing in maybe the length, the width, and the depth of this particular rectangular prism. And you'll notice that each one of these formal parameters here, so we actually have 3 formal parameters listed out, and they're separated by commas. And each one of them has a type and a name. So we're specifying a type and a name for each one of these formal parameters. So it's not unlike what we do whenever we actually declare a variable. And what we're actually doing is declaring a variable here that can be used inside of this particular function. So you can actually make use of L, W, and D, as we'll see inside the function body. We can have empty formal parameter lists, so we can just have open paren, close paren, and we saw that before whenever we used the size function. So we had maybe some particular string that we had defined, so string x, and then we assigned it to hello. I think that's what we did in our previous program. And then we may have x dot size, open paren, close paren. So you can have functions in which you don't have any arguments being specified here. Here you would have to specify 3 arguments that would be passed into this particular function. All right, so this is the actual function body. So we have that open brace, closed brace that's defining the function body. So we can have lots of lines of code in here, and we can have any sort of control structures that we've mentioned, so sequence, selection, repetition, control structures nested inside of other control structures. So that's not a problem. And what we're doing here is just simply multiplying the length times the width times the depth to come up with a volume, and we're returning that value. So this is actually a keyword within C++, and it's just saying that once we evaluate this particular expression here, return it to whoever called us. And that may seem a little bit odd, but we're going to look at some examples of what that means to actually call or invoke a function. Okay, so once we've created a function definition, then we can go and use that function in our program or in other programs. And so to use a function or to call a function, all we have to do is simply specify the name of the function and supply the appropriate argument. So in our case, we had to supply the length, the width, and the depth of some particular rectangular prism. And from that, we can calculate the volume. And since in that particular case, that function returned a value, normally we would have a statement like this, where we would call the function with whatever arguments we had, and in this case we had the same value for the length, the width, and the depth, and then it would return the appropriate value, and then we could store that value into an integer variable and then make use of it in other places in our program. So this is basically what's going on whenever we call a function. We're just specifying the name and the appropriate arguments if there are any arguments. All right, so now that we've looked at the function definition and the structure of a function and also how to call a function, let's try to answer the question of why we use functions in the first place. Because we're not required to use functions in C++. We could simply write all of our code inside of the main function, but it may be very large, so we may have thousands and thousands of lines of code just inside of main. But if we're able to write functions, which we should do, we can look at reusing those functions. So once we have a size function or an at function or a volume function or whatever it may be, we can reuse that not only in a single program but multiple programs. Also, besides code reuse, we can do just a simplification of the program construction. So there may be several logical tasks that need to occur in a particular program. And if we're able to decompose that program down into those logical tasks, then we can probably translate each one of those logical tasks into a particular function. Also simplifying testing. So once we have our program constructed, we can go about debugging or testing our program and maybe isolating the problems down to a specific set of functions or maybe just a single function. So there's no reason to go in there and continue examining code once you've verified that a particular function works. And the last thing I have listed here is parameterization. And so this kind of ties in, I guess, with code reuse as well. So we hopefully write our functions in a generic way, and they are parameterized so that we can pass in different values. So when we're talking about our volume, or maybe volume of the rectangular prism function, we could pass in different values for the length, the width, and the depth, and still have that function calculate the appropriate value for those particular arguments that we supplied. So these are some of the main reasons why we use functions.